Hello, students. I forgot to put the date, but today is March 25th. For our Do Now, we will complete the positivity chart. Our objective will be to continue working with the power rule of exponents, and our essential question asks, what does it mean to raise a power to a power, and what is the power rule? We will complete our Do Now. We will complete the work page, the exit ticket, and show our work. If you don't finish in class, you can finish for homework, but show me everything that you have gotten done. So remember, if you did not complete your integer puzzle activity from yesterday, please complete it using the corrected link. And I'm hoping that you've made a copy and followed the renaming directions. Maybe we'll have a few minutes to work on it together in class. We will get back to our exit ticket. But for now, we have a positivity chart to complete, something that went well this week, something that you're good at doing, and something you're thankful for. And of course, I wrote my students. So let's get into the math. So what we have here is 2p to the second power, q to the fifth power, all of that raised to the sixth power. So we have to multiply the 6 times every exponent inside the parentheses. Well, the 2 does not have an exponent, but we know the rule, that's an invisible 1. So 1 times 6 is 2 to the 6, p, 2 times 6 is 12, and q, 5 times 6 is 30. Now let's evaluate that further. 2 to the 6 is 2 times 2 times 2 times 2 times 2 times 2. So that is 64, and then we have that P12, Q30. So number 18, negative 7 to the second power. Negative 7 times negative 7 equals a positive 49. So this is going to turn 49. So we will have 49, and then our A will be 8 times 2, 16, and our B, 3 times 2, 6. And then number 19, we have 4, and there's an invisible exponent of 1 there, c to the negative ninth power, d to the second power, and then all of that inside the parentheses is raised to the second power. So we'll have 4, 1 times 2 is 2, c, negative 9 times 2 is negative 18, d, 2 times 2 is 4. Now, 4 to the second power is 16. 4 times 4 is 16. The c to the negative 18th power needs to go in the denominator with a positive exponent of 18, and then we will also have our d to the fourth power. That's our final answer. Number 20, we have negative 3 raised to the third power, so that's 1 times 3. So negative 3 times negative 3 times negative 3 equals negative 27. So it will turn positive and then turn negative again. So negative 3 to the third power is negative 27. Then we have m, negative 2 times 3 is negative 6, and n, negative 5 times 3 is negative 15. So we need to rewrite this with those negative exponents taken care of, and those m and m will be put in the denominator, which allows us to make the exponent positive. So it will be negative 27 in the numerator, followed by m to the sixth power, n to the 15th power in the denominator. And that's our final answer. Number 21, we have 5, and that 5 is raised to the first power, so it's 1 times negative 2. So that would be 5 to the negative 2 power. K, 6 times negative 2 is negative 12. And all of that is going to have to go in a denominator under 1. So 1 over 5 squared k to the 12th. And number 22, we have 2a to the fifth, b to the negative 2 power. So we have an invisible exponent of 1 on the 2. So that would be 2 to the negative 4th power. 1 times negative 4 is negative 4. A to the fifth, 5 times negative 4 times negative 4 is negative 20. And b, negative 2 times negative 4 is a positive 8. So the only thing that's going to stay in the numerator is the b with the positive exponent. In the denominator, we'll have 2 to the 4th power. Well, let's evaluate that. 2 to the 4th power is 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. So let's write that fully evaluated in the denominator. So that would be 16a to the 20th power, and then that's our final answer. And in fact, let's go back to number 21. We could have done that here too. We can make that, instead of leaving it, we can make that 5 times 5, which is 25. So now we've got some mixed practice. So we're going to put all the rules together. So we'll start with, remember, grouping symbols are always taken care of first. So the exponent of 2 applies to everything in parentheses. So that will be 6 squared w, 8 times 2 is 16, times 5w to the third. Now 6 squared is 36, and we have w to the 16th, times 5w to the third. 36 times 5 is 180. And then when we multiply, we add the exponents. So on the w's, 16 plus 3 is 19. And then that is our final answer. So let's go to number 24. We have negative 4 to the third power. That's negative 4 times negative 4 times negative 4. So that's negative 64. A, 2 times 3 is 6, times 2a to the 7th power. So remember, the power rule, we multiply. The quotient, the product rule, when we multiply exponential terms, we add the exponents. So now we have negative 64 times 2, which is negative 128. And a, 6 plus 7 is 13. And that is our final answer there. On number 25, another multiplication problem combined with a power to a power. I'm just going to copy the left side and evaluate the exponents only first, so you can kind of see it step by step. So I have 5 to the second, p to the, because the 2 applies to everything. Everything, if it has an exponent, an invisible 1, it's multiplied by the 2. If it has a 4, it's multiplied by the 2. So on the p, 4 times 2 is 8. And then 3 to the second power, and then p, 3 times 2 is 6. So now 5 times 3 is 15. I'm going to start this over. Let's just do the inside first. 5 times 3, 15. P, 4 plus 3 is 7. Then we'll raise the whole thing to the second power. Now we have 15 raised to the second power. That's 15 times 15, which equals 225. So we have 225 on the p squared, and then p, 7 times 2 is 14. And that's their final answer. That's how to do that problem. I should probably make these bigger so I can read them better. Okay, let's work inside first. X to the negative eighth times x to the third would be x to the negative fifth power, y to the negative second times y to the third would be y to negative 2 times y to the ninth will be y to the seventh, and then all of that is raised to the fourth power. So that would give us x to the negative 5 times 4, negative 20, y 7 times 4 is 28. So now x is going to need to go into the denominator. In the numerator, y to the 28th power. In the denominator, x to the second power, and that's final. Now number 27, 56k to the 28th power divided by negative 2k8, and all of that is raised to the third power. So I'm going to work with the denominator first. So we're going to have negative 2 to the third power, k to the 24th power. So when I evaluate that negative 2 to the third power, 56k to the eighth in the numerator. So negative 2 times negative 2 times negative 2 is negative 8k to the 24th power. Now remember, when we divide, we subtract exponents. So 56 divided by negative k is negative 7. And 28, this is a 28. 28 minus 24 is 4. And that's our final answer. So 56k to the 28th minus negative k to the 24th is 7k to the 4th. And number 28, 12c to the third, d to the seventh, all of that raised to the second power, divided by 18, c to the eighth, d to the 10th. So first I'm going to work with the numerator. So 12 to the second power, c to the 3 times 2 6th power, d to the 7 times 2 14th power, divided by 18, c 8, d 10. So I can simplify 12, well, first I have to evaluate 12 squared. So 12 squared is 12 times 12, which is 144, c 6, d 14, divided by 18, c 8, d 10. So 144 divided by 18 is 8. So this cancels and becomes 8. C6 minus 8 is negative 2. D, 14 minus 10 is 4. So a little trouble with my pen there. So now we've got to work with putting that c to negative 2 power in the denominator. So that will be, we'll have 8d to the fourth in the numerator, c with a positive exponent of 2 in the denominator. And there's our final answer. We have our last two problems. So we're going to work, just copy down the left side, and we're going to work on the right side first. So we have negative 4 raised to the third power. M 2 times 3 is 6. N 7 times 3 is 21. And it looks like we're headed toward like terms here, which usually happens when you add or subtract. Now, that negative 4 to the third power needs to be evaluated. So I'll write the left side down first. So negative 4 times negative 4 times negative 4 will be negative 64. M to the 6, N to the 70, 7, 14, 21, that should be 21. Okay, so 40 minus 64 is going to be negative 24. and that's m to the 6th n to the 21st power. And finally, we're going to work on the right side first, so I'll just copy down. Oh, nope, we have to work on the left and right side first. So let's start with the left side. So it will be 4 to the 3rd power. I think I'm going to evaluate this as I go. 4 to the 3rd power, 4 times 4 times 4 is 64. A, 8 times 3 is 24. B, 2 times 3 is 6. Minus, then we have 3 to the 2nd power. That's 3 times 3, which is 9. And then we have A, 12 times 2 is 24. And B, 3 times 2 is 6. So it looks like we have like terms again with the A24, B6. So we just need to subtract 9 from 64. So 64 minus 9 is 55. And we have our A24, B to the 6th power. So let's go to that exit ticket and see if we can figure out a way to prove the power rule with an example. So if we have 2 to the 4th power, that would be 2 times 2 times 2 times 2, which would be 16. If we were to take 2 to the 4th power and raise that to the 2nd power, that would be the same as 2 to the 8th. So that should be the same as 16 times 4, or 16 times 2. So 2 times 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 2. 4, 8, 16, 32, 64, and then 64 and 64 is 128, 128 and 128 is 256. So that's 256. And if you were to take 16 and multiply it by 16, so in other words, if you took this and raise it to the 2nd power, let's see what we get. 6 times 6 is 36. 9, 16, and that adds up to 256. And our answer checks. So we just proved the power rule with an example. So thank you for all your hard work. If you finished early, I have a little mindful arts activity that you can do that's really fun. You can make swirls. And I also have a game where you can make as many words as you can find using the letters in the wheel, but they all have to have the letter R in there somewhere. So thank you for your attention today. Thank you for your hard work. Keep working hard. We're almost in April, and then 3 months of school left, and then a well-deserved summer vacation for you. So remember, keep practicing, because as you do, you'll be great.